Hi everyone, this video is on the mixed exercise 9 question 6. We have this equation of a curve and we want to find the coordinates of the stationary points of the curve. So whenever we want to find the stationary points of a curve, we need to differentiate the function first, and then we can set that equation of the first derivative equal to 0, and the solutions to that are going to be the x coordinates of the stationary point, and then we substitute the stationary points, the x coordinates, into the equation of the curve to get the y coordinates. So in this case, for the first derivative, we want to differentiate cos squared x, and we can use the chain rule because cos squared x can be just rewritten as cos x and then bracket is squared. So if this helps, you can always do this because this shows that this is the chain rule. The power comes down, and then the derivative of inside cos x differentiates to minus sine x, and then of course we write down the bracket with the power minus 1. So it's going to be cos x again. Now for the sine x, that differentiates to cos x, so cos x, and we can simplify this now. Minus 2 sine x cos x plus cos x. So this is the derivative, and now we can solve this equation to find the stationary points. dy by dx is equal to 0, which means minus 2 sine x times cos x plus cos x is equal to 0. We can take a factor of cos x. Cos x is cos x times minus 2 sine x plus 1 is equal to 0. Now, in order to solve this equation, there are two cases. Either cos x is equal to 0, or the bracket is equal to 0. So minus 2 sine x plus 1 is equal to 0. Okay, for the first equation, for the equation cos x is equal to 0, remember that the values of x are between 0 and 2 pi. And obviously when x is between 0 and 2 pi, the only values that make cos x 0 are pi over 2 and 3 pi over 2. So these are the only two values. And for the second equation, let's rearrange that, because we are going to have sine x is equal to a half. And for sine x is equal to a half, if you do this sine inverse of both sides, one of the values of x that you're going to get immediately is pi over 6, because sine of pi over 6 is a half. And also another value that we are going to get is when we do pi minus pi over 6, because sine repeats. And this is always a good trick, the cos diagram. So because pi over 6 is here, but remember that there is also another region that that's going to have a positive value of sine, and that's the second quadrant. So for the second quadrant, we do pi minus pi over 6, which gives us 5 pi over 6. So this is these are the values for x and the solutions of x in the second equation. Okay, now we have 4 different solutions, and for each of them we need to find the corresponding y coordinates, and all we need to do is just simply substituting each of these x coordinates into the equation of the curve to get the corresponding y coordinates. So when x is equal to pi over 6, then y is equal to 5 over 4. When x is equal to pi over 2, y is equal to 1. When x is equal to 5 pi over 6, then y is equal to again 5 over 4. And finally, when x is equal to 3 pi over 2, and this time y is equal to minus 1, because this is the opposite to pi over 2. Okay, so these are the coordinates, and yeah, that's it for this video, and thank you for watching.